to our last topic of the reactions unit. We're going to talk about something called redox reactions. Redox stands for something, and so that's what we're going to be learning about and what it is. So what are redox reactions? This picture kind of summarizes it because it shows an electron moving from the green compound to the red compound, and that's what redox reactions are all about. Redox stands for reduction, oxidation, reactions. And rather than saying reduction, oxidation, we shorten it to say redox. In a redox reaction, electrons move from one atom to another, or from one ion to another, or from one compound to another. The main idea here is that electrons are in motion. There's two ways you can remember oxidation and reduction. I'm going to focus on my favorite way because it has to do with this really cool line here. The way that we remember what oxidation and reduction is by saying Leo says grr. If you didn't know, Leo is a lion. So Leo stands for loss of electrons is oxidation. So that's a vocabulary word for us to remember. Oxidation means electrons were lost. And grr stands for gain of electrons is reduction. So Leo the lion says grr helps us remember that loss of electrons is oxidation and gain of electrons is reduction. So what exactly does this mean? Let's focus on the left-hand side right now. Oxidation, again, is losing electrons. That means that the substance is going to become more positive. Remember that electrons are negative. And so if you lose your negative things, you're going to be more positive. So what we're going to see is that oxidation is a process in which the charge goes up. Let's look at the right-hand side of the screen now. Reduction. Reduction is gaining electrons. And since electrons are negative, that means the substance is going to become more negative. If you gain negative thoughts, negative feelings, negative things, your overall charge is going to go down. So if the charge is decreasing, going down, that's called reduction. Okay, so what are these numbers that we're talking about? Oxidation numbers are basically like charges, okay? For our purposes, just think of them as synonyms. Oxidation number means charge. So an element that is not in a compound has a charge of 0. That means its oxidation number is 0. So O2, that's a plain element. It has an oxidation number and charge of 0. Ag, plain element, has an oxidation number and charge of 0. And K, potassium, plain element, has an oxidation number of 0. Any element that's by itself has an oxidation number of 0. The oxidation number of an element in a compound is the ion's charge. So we're really going to focus on ionic compounds, and so their oxidation number is basically just the same thing as its charge. This can often be found on your ion sheet. And finally, the sum of the oxidation numbers in a compound must add up to 0. We won't use that too often, but it's useful to know. All right, so an example here, the box there, by the way, is supposed to be an arrow, okay? So what we're going to do is assign the oxidation numbers. Sodium is an element by itself. So above it in red, I wrote 0 to show that its oxidation number is 0. Chlorine has an oxidation number of 0 because it is, again, an element by itself. Now, NaCl is a compound, and so Na and Cl have charges of +1, -1, so I wrote those numbers above them. Okay, so now the question is which element is oxidized? So from the left-hand side of the equation to the right-hand side of the equation, which element experienced an increase in charge? Because remember, oxidation is if the charge goes up. Well, that would be sodium. Sodium went from 0 to +1. That's an increase, that's oxidation. And then which element is reduced? That is when it gains electrons and its charge decreases. So that's going to be chlorine because its oxidation number went from 0 to -1. Okay, this is just kind of a visual of that. Na had its charge go up, that's called oxidation. Cl had its charge go down, that's reduction. Feel free to pause the video here if you need to copy that down before we move on. Okay, so we're going to practice together. We are going to balance the equation and then identify the element that's oxidized and the element that is reduced. So starting off, we'll balance the equation with a 3 in front of the sulfur and a 2 in front of the iron. Next up, we are going to figure out their oxidation numbers. Iron and sulfur, look above them, I've put a 0 to show that their oxidation numbers are 0 because they're elements by themselves. In the compound, sulfur has a charge of -2, that's from your ion sheet, and to balance it out, iron has a charge of +3. You can think of it as undoing the crisscross on the ionic compound Fe2S3. So, what element was oxidized? That means that its charge increased. That's going to be iron because its charge went from 0 to +3. That's an increase. And which element was reduced? That's going to be sulfur because its charge or oxidation number went from 0 to -2. All right, in this next one, again, remember the box there is supposed to be the arrow. We're going to balance and identify the element oxidized and the element reduced. So first thing is to realize that this is a synthesis reaction. So if we put aluminum and oxygen together, it's going to be an ionic compound, and we need to crisscross the charges. That's going to be Al2O3. To balance this equation, 6 aluminums, 3 oxygens, and 2 aluminum oxides. Next up, assigning oxidation numbers. Aluminum and oxygen both begin as 0 because they're plain elements by themselves. Aluminum and oxygen in the compound now have charges because those are their ion charges. You could again find those on your ion sheet. So what element was oxidized? What element increased in charge? That's going to be aluminum because it went from 0 to +3. Oxygen went from 0 to -2. That's a decrease, and so that's going to be the element reduced. Okay, what are some real-life examples of redox reactions? These are actually quite common. Iron rusting is a great example of oxidation reduction. The iron is oxidized, and the oxygen in the air is reduced. Hydrogen peroxide, sanitizing wounds like cuts and scrapes, that's an oxidation reduction reaction as well. There's a transfer of electrons when hydrogen peroxide reacts with the enzymes in your skin. Photography development, I feel like maybe not all of us know about that because it's from the 20th century, but back when we had real film and we had to develop it, that was a redox reaction. Bleach whitening laundry, bleach reacting with the stains in your clothing is a redox reaction, and silver tarnishing is another great example. Really any metal tarnishing or rusting is going to be a redox reaction. So here's rusting. It requires oxygen and water to be present. It's a very slow process since the water droplets don't have very many ions. They're not great electrolytes, but rusting will happen. It just might take a while. Corrosion, very similar. It's the loss of metal resulting from an oxidation reduction reaction of that metal with substances in the environment, again, such as oxygen and water. Corrosion occurs faster if water has a lot of ions in it, such as salt water, or places where the roads are salted, maybe due to winter weather. Corrosion is going to happen faster in environments like that. To prevent corrosion, iron can be coated with another metal that is more resistant to corrosion, like zinc. This is called galvanized iron, and it's pretty common. We don't want our iron to rust and be lost and become weak, and so we can galvanize it with another metal on top. All right, that is it for the video. Pretty short topic. If you have any questions, please let us know, and we are happy to help. Thanks for watching.